Hi, my name is David Morrison. I'm a space scientist at NASA Ames Research Center. For the last 2 years, I've been answering hundreds of questions from the public about 2012 and the supposed threat to Earth. And so now I want to take a chance to talk to some of you more directly. There is no threat to Earth in 2012. There is no danger. All of the talk about a doomsday is a big hoax perpetuated on the internet and with people trying to make money. So please don't worry about it. Let me talk about some of the specific things. There's been a lot of talk about a Planet X or Nibiru as a giant planet that's going to hit the Earth or at least come very close in December 2012. Simple fact is Nibiru does not exist. Aside from worrying about the weird places the ideas came from, all you have to do is ask the astronomers. If Nibiru or Planet X were going to come into the inner solar system in 2012, astronomers would have been tracking it for the last decade, all over the world, amateur as well as professional, and it would be visible now to the naked eye. It's not there. It's a no-show. There's nothing to worry about some object coming and striking the Earth or damaging us. There's also been concern about a so-called galactic alignment, because in December of every year, the sun is roughly in the direction of the galactic center as seen from Earth. This happens every year. It really doesn't mean anything, and there's nothing special about 2012. If you're not worried about December 29, don't worry about December 2012. In fact, alignments, although it may sound scary to some people, are just not an issue for scientists. There are no special forces when planets align or the sun aligns. It's sort of a curiosity, but not something of real scientific interest. There's also been concern that somehow the Earth's poles are going to flip. No one quite explains how this could happen, and if you're talking about the rotation pole of the Earth, that can't change. It never has and never will. Some people, however, are concerned about the change in the magnetic polarity, a shift of the North and South Pole, which does take place every few 100,000 years. But there's no reason to think it will happen in 2012, and actually no evidence that it would do any harm to us, even if it did happen. Some people couple this with ideas of solar outbursts, of flares, or coronal mass ejections, which could do great damage to the Earth. Well, the solar maximum takes place every 11 years, and occasionally there is some damage to satellites in orbit. And we see bright aurora or northern lights here, but very little real damage is done. And there's no solar maximum predicted in 2012. The next solar maximum is predicted for the spring of 2013, and it's actually anticipated that it will be much lower than usual. Again, all this 2012 talk is just a hoax. It's a fake. It's nothing you should worry about. I get questions from many people who are really scared, even some young people who have said they're contemplating suicide, this sort of thing. It's really sad. And the point of my talking to you now is just to explain to you that there is no problem there, and that the many things you see on the internet and YouTube where people claim that there is some horrible threat about to descend on us are not true. Don't worry about 2012 and enjoy 2013 when it comes.
Kaku is an astrophysicist and author of The Physics of the Impossible. Sir, good morning to you. Welcome back here.
Glad to be on your show.
Now, what I'm reading here scares me to death. Should I be that way?
That's right. We're talking about a potential Katrina from outer space. Katrina caused about $100 billion in property damage, and unless we begin to make efforts now to reinforce our satellites and power grid, we could have something maybe 10 times bigger than Katrina, because we're talking about the loss of all electricity and all satellite activity. We'd be thrown 100 years back into the past.
Michio, has this happened before?
in 1859, we had a humongous storm that wiped out telegraph poles, and we tried to then estimate what kind of power could do that. And we now realize that we are very young in the space age. If something like the 1859 storm hit again, it would literally paralyze all the United States, not just for a day or an hour, but for months to years. Transformers would short circuit and burn out. Satellites would be fried to a crisp. And the sun, however, has these storms every 11 years. Every 11 years, the magnetic field flips. But in 2012, we do expect perhaps another big one.
Well, we have never before in our history, in human history for that matter, relied so much on technology as we do today. And that's part of what they found in the study, because we rely so much on our ability to communicate through our computers that they would all go down, which would handicap not just New York, but really the eastern half of the United States. That's what the study finds, which would be far worse than the blackout of New York from 4 years ago, Michio.
That's right. Those blackouts only last for a few hours to a day. But if you start to short-circuit all the transformers and blow out the satellites and fry the communications grid, then you're talking about knocking out the United States for months before we can get enough rescue crews and repairmen to handle not just one city, but hundreds of cities around the United States.
You know, Michio, sometimes you come on here and you sound like the doctor of doom and gloom. Does something like this keep you up at night?
It does, and I think with Katrina, you know, engineers knew that Katrina could happen, but they did nothing because they said that it's not going to happen while I'm around. Well, now we learned the lesson. You have to prepare for things, especially when you know that at some point it's inevitable that we're going to have another big one, like we had back in 1859, except this time we're totally dependent on electricity.
Michio, thank you.
And that's why we have satellite and rocket experiments that are trying to fill in those missing pieces of the puzzle.
To understand why it is important to study the northern lights, we must first understand how they work. The sun is constantly emitting streams of electrically charged particles in all directions.
This stream of charged particles is called the solar wind. Since the sun is 93 million miles away, it takes about 3 days for the particles to reach Earth. As the solar winds flow by the Earth, it causes a disturbance in the Earth's magnetosphere. This disturbance energizes currents of particles which are steered by magnetic forces towards the Earth's poles. These energized particles collide with oxygen and nitrogen atoms in our atmosphere, which produce the colorful light that we see in the aurora. Although beautiful to watch, these currents of particles are actually a form of electricity, which can generate up to 800 gigawatts of electrical power. This electrical energy flowing in the upper atmosphere can cause currents to flow in the ground, producing disruptions in communication, electrical outages, and fuel leaks. The high-energy particles flowing in space that often accompany these storms can also hit satellites, damaging their sensitive electronics and creating false commands. This can wreak havoc on television, pager, and other communication services here on Earth. NASA researchers hope to find new ways to predict not only when these storms will hit Earth, but also hope to find ways to reduce their destructive effects when they do.
What are some of the tools you use to study the northern lights?
We have satellites that seem to be able to look at everything that goes on with a solar storm and the production of aurora, literally from cradle to grave. We have satellites that watch the solar surface for the big leaps of matter and energy. We've got satellites that look at the wind in between the planets to watch what that's doing. We also have satellites that are in tighter orbits to the Earth so that they can look at the poles of the Earth and see the aurora happen. They can also measure electric fields in space and magnetic fields in space. So they can also see the invisible flows of particles around the Earth. And then finally, we have rockets that go up into the aurora from the bottom at the same time that the satellites are passing overhead. So we can kind of see the physics in between, flows of particles inwards, and the rockets see the electrical fields that are set up by these things. And we get this complete picture from rockets and satellite observations.
So why is Norway such a popular place to study the northern lights?
It turns out that Norway is in a place that's very favorably located to actually see the aurora directly overhead. So you can launch the rockets directly up very quickly to get into the aurora at the time that they're changing.
Dr. Odenwald, how do you think NASA research is helping us better understand the aurora and its impact on Earth?
Well, NASA's invested an awful lot of time and effort into providing scientists with the technology and equipment they need to really make powerful and insightful discoveries about how aurora work. And that feeds into our knowledge of the environment that we live in space and how that affects human technology, our billions of dollars of satellites that we have there, the health of astronauts because of the energetic particles. It all works together. And if we can deeply understand space weather effects with the help of NASA technology, it's going to be much easier for us to operate in space, and that's the direction that we want to go as a civilization.
Earth has just been visited by the perfect solar storm.
The sun kicked up this just incredible solar flare and a massive amount of energy headed towards Earth.
Not only was this storm one of the two most powerful on record, it was also one of the fastest. Ejecting from a sunspot aimed directly at Earth, it raced from the sun to our planet in less than 18 hours.
Now it takes a really fast rocket ship years to get to the sun. This storm, this cloud of electrified particles, managed to get here in less than a day. That's incredibly fast.
Fortunately, the perfect solar storm took place in 1859, when the only technology vulnerable to the onslaught was the telegraph. Since the era in which we have become dependent on high technology, we've yet to see another perfect solar storm. The question remains, could it happen again?
What if we have another one like that? Can we have another perfect storm? Well, I'd say yes, we can. There's no doubt about that. The effects that would be on us today compared to 1859 could be devastating.
The effects on Earth and on our communication systems, we don't exactly know. That's the scary part.
It's likely that our modern technologies would be battered like beachfront houses during a hurricane. Imagine if we lost all the satellites that relay cell phone calls, television signals, and bank transactions. And what if, at the same time, the failure of power grids cascaded whole regions into darkness for hours or weeks? If these essential services couldn't be restored quickly, chaos wouldn't be far behind.
It would definitely be a ripple effect upon society and every man and woman and child that lives on this earth.
Solar storms can be as hard to predict as hurricanes. While forecasters lack the technology to foretell the next perfect storm, they do know that one would be more likely to hit at the peak of the sun's 11-year sunspot cycle.
What happens is the sun reverses the direction of its magnetic field every 11 years. So in 22 years, it reverses and comes back to where it was.
As we near the reversal every 11 years, the number of sunspots increases, and there's a spike in solar activity.
We call that period solar maximum. And those periods are interspersed about 5 years apart from periods we call solar minimum.
So you have this 11-year back and forth between the sun being sometimes very ferocious and it goes crazy and it's like the 4th of July with fireworks all the time. And then it starts to ramp down, and for a few years it gets quieter until we get to a low point where there's a firecracker now and then, but not a lot going on.
Just like hurricane seasons, solar maximums vary in intensity. Some produce many more powerful storms than others. Although we're currently at solar minimum, scientists are watching carefully to see what mayhem the next solar max might unleash.
So the last solar maximum was in about 2001, and so the next one ought to be about 2012. But there are different predictions. The whole field of solar physicists is basically waiting with bated breath to see what actually happens.
There are some wildly divergent opinions on what's going to happen. One group is suggesting that this next solar cycle could be the strongest in modern times.
If those predictions are correct, Earth could be in for a wild ride.
We might have to worry about a repeat of the 1859 event. If that were to happen today, it would wreak untold damage.